All right, this is lesson 11.1a, simplifying radicals. So our objectives today are to simplify radicals involving products. So we're going to do example some perfect squares you need to know, because today we are not using our calculator to find the square roots and finding the about. We're going to just simplify radical expressions. That means some of the answer is going to be still in radical form, which means a square root. Radicals are square roots. Signs. So some perfect square roots we do need to know. Squares are 4, 9, 16, 25, 36, 49, 64, 81, and 100. So if I look at example 1, simplifying each radical expression, I have 192. So I need to find one perfect square, the largest one, number that can go into 192. Perfect square, largest perfect square. Big chance it will be in between the 4 and the 100. So I'm going to check, and I do 192 divided by 4, and that's 48. Well, so I have 4 and 48. Well, I know that 4 can go into 48, so that's not my biggest perfect square. So 192 divided by 9 is, oh nope, not even close. So 192 divided by 16 equals 12. So 16 times 12. Well, I know that 4 can go into 12. So that is not a perfect square completely, and I could go all through these numbers, and 16 times 4, let's see what 16 times 4 is. That's 64. Oh, that's a perfect square. So let's see if 64 can go into 192. It can. It's 64 times 3. Well, I know 3 is not a perfect square. There's no perfect square that can go into 3, so I'm guessing it's going to be 64 and 3. 64 is my biggest perfect square that can go into it. So I'm going to put underneath my square root of 192, I'm going to break it up into 64 and 3. You always put your perfect square first. That's what I always do. And I circle the perfect square. That means I'm going to break it up into square root. What's the square root? That's the question you ask yourself. What's the square root of 64? Well, the square root of 64 is 8. And what you say is whatever's not circled goes still inside the square root. So it's going to be 8 square root of 3. And there's your answer. So let's try B. 50. Well, what's the perfect square that can go into 50? Well, it's not 4, it's not 9, it's not 16, 25. Yes, 25. That works. So I have square root, and I have 25 times what gets me 50 times 2. And then I circle 25. Well, the square root of 25 is 5. And what's left over stays in the square root. So it's 5 square root of 2. Alright, now I have something on the outside that's at -5. Just leave it there for right now. So I'm going to leave it -5. Well, I need to find a perfect square root that goes into 300. Well, the biggest one that I could do is, if I look, I'll start with the biggest number. 100. Well, 100, does it go into 300? Yes, it does. 100 times 3 gets me 300. So, I'm going to circle 100. You put your -5 times sign. And the square root of 100 is 10. And then I have left over a square root of 3. So I have negative 50 square root of 3. 18. What is a perfect square that goes into 18? 4? No. 9? Yes. 16? Oh, now we're going a little too high, so it's 9. 9 times 2. So the square root of 9 is 3, and left over is 2, so it's 3 square root of 2. Alright, let's try example 2. Okay, so this time we added variables. Now, a perfect variable, perfect square root variable, is the highest even. Even. And then we'll break it up if it's an odd number. So if I look at it, we'll start with a number and we do 45. So I could break up 45 and that would be 9 and 5. Notice I'm giving myself some space on the 9. Now I have a to the 5th. Now my highest even number for a to the 5th is a to the 4th. And I have 4. Now I need one more, so I'm going to bring it over to the other side with the 5. Now I'm going to break up 9a to the 4th. So that would be 9 would be 3, and you divide by 2 with the exponents. So instead of a to the 4th, it would be a to the 2nd. And then what's left over? 5a. B. Again, I'm going to break up 27. I have 9 times 3. Oh, not giving myself some space. 9 times 3. N squared. That's an even number, so it's just going to go with the n. So I break up n to the n squared. So it's break up 3 would be 9 would be 3, and to break up n squared would be n, and I have left over a square root of 3. Oh, I have something on the outside. Don't worry about that like we did before. So you leave negative a alone. Find out a number that can go into 60. That would be 4 times 15. 4 is a perfect square. You can't do 6 and 10. They're not perfect squares. Break up a to the 7th. 7 is an odd number, so you go the one right underneath 7, which would be a to the 6th. And I have still need one more, so that's 15a. So now I break up 4a to the 6th. So I have negative a times 4 is 2 times a to the 6th would be a cubed. What's left over is square root of 15a. And then you multiply the negative a times 2 times a cubed. So that would be negative 2a to the 4th. Remember, a has a exponent of 1, so 1 plus 3 is 4. And then you put your square root of 15a. Okay, D. This time it has no numbers, so all you have to do is just talk about the variables. So the highest even number for x would be x squared, and the highest even for y to the 5th would be y to the 4th times y, because I still have that one y left over. So then I break up the perfect square, so the square root of x squared is x, and the square root of y to the 4th is y squared. And then square root of y is left over. I'd like you to try E by yourself. Please put me on pause. Check it out. Alright, so I broke up 20 to 4 and 5. broke up a to the 11th to a to the 10th and a, and b squared is already a perfect square. Then I square rooted the 4a10b squared to 2a to the 5th b with a square root of 5a attached. Okay. Example 3. You first multiply the 8 and the 12 together. So 8 times 12 is 96. And then you find a perfect square that can go into 96. Well, I know 4 can. I know that 4 can. It's 4 times 24. But I know also 4 can go into 24. So I know it's not a big enough number. So then I tried 16 and I got 16 times 6. So this one's out, and 16 times 6 works the best. So I'm going to put square root of 16 times 6. And the square root of 16 is 4 square root of 6. B, I have 13 times 52. And that's square root of 676. And when you have a big number like this is when you check and see if it is a perfect square already. And 676 is 26. And since it's a perfect square, it's just a whole number. It's 26. C. First you multiply the 3 and the 4, so that makes 12. And then you do 2b times 10b, which makes it 20b squared. Now you break up 20b squared, so it's 12 on the outside. So it's going to be 4 and 5, and b squared is an even number, so you leave it like that. And so it's going to be 12 times 2b square root of 5. And 12 times 2 is 24. Have the b, and then square root of 5. I'd like you to try D and E by yourself. Please put me on pause and check it out. Alright, so I multiplied them together. I got 5 square root of 18c squared, broke them up. And the answer is 15c square root of 2 for D. And for E, I multiplied them and got 12 square root of 50a to the 5th, broke up 50a to the 5th. And my answer is 60a squared, square root of 2a. Alright, let's try example 4. There isn't much to do on example 4. I need to put out a little bit more information on here. I need to put 1.5h. And then for I'm going to have h equal 500 and h equal 25. Alright, for this you will need a calculator. So first of all, you're going to do square root of 1.5 times h, which is 500 on that one. And so that's the square root of 750. And the square root of 750 is about, just round to the nearest whole number, and that would be about 27. So for B, 1.5 times 25. For your homework, they might just have it where they give you the word problem and you just put in the number for where it is. So this is square root of 37.5. And that number is about 6. And that's all the stuff I have on that one. All right. Goodbye.